Good morning friends. I hope everyone is doing well. In this video, we will discuss about constructing a Turing machine for a unary number to binary conversion. Okay, we want to construct a Turing machine for converting a unary number to binary representation. Okay, so now we will discuss what is meant by unary number. Let's take that I have a number 2 which is a decimal number. In unary number, I will convert it as 1, 1. If 2 is there, how I can convert into a binary number? I will get 1, 0. If it is 3 is there, in unary number, I will represent as 1, 1, 1. In binary number, I will represent as 1, 1. If it is 4 is there, okay, then in unary number, I will represent as 4 ones. In binary number, I will get 1, 1, 0. Those who don't know how to convert a binary number to a decimal number, you can watch 0 you will get, means you will divide the 4 by 2, quotient you will get 2 and remainder is 0. Again divide by 2, you will get the quotient as 1, remainder as 0. Further you cannot divide the 1 by 2, so you leave it and take the from the bottom to the top, you will get 1, 0, 0. Okay, if it is 1, in unary number you will represent as a 1, in binary representation also it will be 1. If it is 5, you will represent as 5 ones and you will get 5 as 1, 0, 1. So, this is the decimal number and equivalent unary number and equivalent binary number. Now, we will see how we can do it using a Turing machine. Let's take it. Okay, I have taken a 1, in unary number it is 1, in binary number it is 1. Okay. For 1, if I add 1 to in the decimal number, I will get 2. Am I right? For 1, if I add another 1, I will get decimal number 2. Here, if I add another 1 into the binary number, what I will get, we will see. 1, 1, if I add, sum will be 0, carry will be 1. So, you will get 1, 0. So, if I add 1 to this, I got 1, 0 of the decimal number 2. Let's take that. For 2, I will add 1, I will get the decimal number 3. So, for the binary number 2, if I add 1, what will happen? We will see. 1, 0, if I add 1, it will be 0, 1, I will get sum as 1 and carry as 0. 0 and 1, sum will be 1 and carry is 0. So, you got the binary number of 3. Similarly, if you take 3, if you add 1 to the decimal number, you will get 4. Now, I will see. Binary number 3 is represented as 1, 1. If I add 1, what will happen? 1, 1, if I do it, the sum will be 0, carry will be 1. Again 1 and 1, if you perform addition, sum is 0, carry is 1 and you get the 1. So, even I got the binary representation 1, 0, 0 if I add 1 to the binary number 3. Is it clear? So, how can I do it? Simply add 1 to these numbers, you will get the binary representation of the next number. So, with this introduction or with this procedure, I will construct a Turing machine for converting a unary number to a binary number. Okay. So, now let me take a small example. The unary number, I will take it as a 3. So, if it is a 3, how can I represent in unary number representation? It will be 1, 1, 1. Blanks will be there and set of blanks. Some infinite number of blanks will be there in the left hand side and in the right hand side. Okay, now watch it. Your inputs are in the form of ones because it is a unary numbers. Inputs will consist of ones. Now, if I take the output 3 ones, it is a unary number 3. If I convert into binary number, I will get 1, 1. In the binary. So, your output also in the form of ones and zeros. So, you could not able to distinguish what is the input and what is the output. Even if you represent input as ones and outputs as also consists of ones and zeros. So, what I will do is that in the representation 0 I will represent as C in the output and 1 I will represent as a D. In the inputs, whenever I read a 1, I will modify it to X. Are you able to understand it or not? Okay, you can modify it to X or anything. So, I can, if I read a 1, I will mark it as a X. output I will read it as, if it is 0 consists of, there in binary number will consist of ones and zeros. So if I get a 0, I will represent in the Turing machine as C. If I get a 1, I will represent as D. Now let's take the 3 ones. What is the decimal number you will get? Sorry, binary number what you will get? 1 1. If it is 1 1, in my representation it will be DD. Are you able to understand? So it will avoid the confusion. At last you will have, in place of inputs you will have X, in place of output you will get DD. So there is no confusion with the input and outputs. So now we will go ahead. So we will write here, your input, if you find a 1, you will modify it as X. This is in the input. In the output, if you see a 0, you have to represent as a C. If you see 1, you will represent as a D. Now go ahead. Now where is the tape head is pointing initially? It is pointing to this first one. I am in the initial state Q0. If I see a 1, what should I do? I have read the 1. I have to modify it as a X. Then what I will do is that I can move to the left or I can move to the right. If I move to the right, I will read the next input as 1. But I need to store the output somewhere, because this 1, I have read the 1. So I have to represent the binary number for it. So either I can store the output in the right hand side of the input, or I can represent in the left hand side. Because I am here, moving to the left is quite easy. So then what I will do is that I am in the state Q1. So this 1, I modified it as a X, and I am pointing to here, because on 1 I modified to X and move to the left. My tape head is pointing to this blank. So this blank, what I will do is that if you get a blank, I will, let me write here. If you get a blank, you have to modify it as what? You should modify it as D, because you have to get the output as 1 here, because you read the input as 1. So if you get a D, if you get a blank, you modify it as a D and move to the right, because you modified this as a D, okay, and move to the right. When you are moving to the right, you are reaching to the state Q0. The tape head is here. So if you see any number of X's, because you need to see the next one. If you see any X, make it as a X, keep on moving to the right side. So if in this case you will get 1X, but next time you will get more than 1X. So X, you are making it as X, move to the right, and you stay in the state called Q0 itself. Now if I see a 1, make it as a X, move to the left. Okay, move to the left. If you move to the left, what will happen? 1, you modified it as X, you move to the left here. Now the tape head is pointing to this one, and you are in the Turing machine, you are in the state called Q1. If you see a X, you simply make it as X, keep on moving to the left, because you need to modify the output. Okay. Now if you see that, you saw how many ones? You saw 2 ones. So what is the binary number for it? It will be 2 will be represented as in binary number as 1 0. According to our representation, what it is? It is DC. But right now you have only D. So when you are moving to the left, if you see a D, you make it as C, you modify it as a C, and keep moving to the left. So this D, previously it was D, I modified it as a C and moved to the left. So I am here currently. Okay. Now I can see a blank, I will modify it as a D. I see a blank, I modified it as a D and moved to the right. Now you saw 2 ones. So in binary number it is 1 0. According to our representation it is D and C. We got the output as D and C. It is doing well till now. Okay. Now where you are making it as a blank, made it as a D. You saw a blank, you modified it as a D and moved to the right. Currently you are here and you reach to the state called Q0. If you see, now what you are seeing, if you see a C, you make it as a C, move to the right. If you get a C, you make it as a C, keep on moving to the right, because I don't want to change this one. And if you see a X, make it as X, move to the right. Okay, so all the C's are finished, all the X are finished. I'm looking at for a 1. If it is a 1, I will make it as X. I will make it as a X, move to the left. This is where I am moving and I reach to the state called Q1. If I see any number of X, I will make it as X, keep on moving to the left. If I move to the left, I am here. Okay, are you able to understand? So now, how many ones you have seen? You have seen 3 ones. So what is the decimal number it is? It is 3. In binary number, how you will represent 3? 1, 1. According to our representation, how it will be? DD. Am I right or wrong? So this C, I have to modify it as a D, move to the right. Okay. If I modify it as a D, then I got DD. So I no need to go to the left. Are you able to understand? Is it clear? Because I should get DD, I have seen a C, I modified it as a D and moved to the right. If I move to the right, I will get here, I am in the state Q0, which is an initial state. Are you able to understand? So, if I see X, I will make it as X and move to the right. Okay. If I see all the X, I can see there is no ones. If it is a 1, I would have modified, but all the ones are finished. If I see a blank, the meaning is that all the ones I have finished, means I have taken all the input ones and I have finished them. Okay, and I got the output. So what I should do? If I see a blank, make it as a blank, move to the left or right. Okay, and reach to the state called Q2, which will get the output for you. So now if you see that we get all the X's and in the output we got the D. Okay, like this you can leave it, or you can do another thing. If you see a blank, you keep it as a blank and move to the left, or you can modify all these X's to the blanks also. That is also okay. But just for simplicity, I will make it I see a blank. The meaning is that I finished all the inputs. I will make it as a blank and I am staying and move to the left and I am reaching to the state called Q2. So what is my output is there? DD. Whether it is correct or wrong? Yes, it is correct. Now we will see this procedure. Okay. Now we will do it is, we will check whether it is working for other binary number, other unary numbers or not. Okay. Now let's take that. I have taken 4 ones are there. Okay. I have a blanks. 4 ones means what? The decimal number is 4. In binary number, what you will get? 100. In our representation, what you should get? DCC. Whether according to this Turing machine, whether we are getting it or not, we will check it. Okay. I am in the initial state Q0. Okay. I am in the initial state Q0. I should get DCC. Keep that one. Okay. Now I am in the initial state Q0. You modify it to X. Simple. And move to the left. And you reach to the state called Q1. Okay. Now in Q1, what you are there? In Q1, if it is a blank, you modified it as a D and move to the right. So this B, you modified it as a D and move to the right. So you are here. Okay. Move to the right and you reach to the Q0. If you see a X, you keep it as X, move to the right. So you are here. Okay. Now again, if you see a 1, you modify it as X and move to the left. Okay. You are modifying this one to the X and you are making it as moving to the left. Okay. You are here. If it is a X, again you keep it as a X and move to the left. Doing well, good. Okay. Now you will be here. This is very important, where the tape head is there and which state you are in the Turing machine, that is important. So if it is a D, you modify it as a C and move to the left. The tape head is pointing to this one. If it is a blank, you modify it as a D and move to the right. You are here. Okay. And you reach to the state called Q0. Blank on D, move right and reach to the state called Q0. If you see a C, make it a C and move to the right. If it is a X, make it as X, move to the right. Again, if it is x, make it as x, move to the right. You will see the 1 last and you are in the state Q0. If it is a 1, modify it as x, move to the left. You are here. And you are reaching to the state called Q1. Q1 on x, make it as x, keep on moving to the left. If you keep all the x's as x and keep on moving to the left, you will get here C. Okay? Now you are in the state Q1. Now if you see a C, Q1, if you are seeing the input as 1, you modify it as a D, move to the right. You are here. And you reach to the state Q0. If you see a x, keep on moving to the right. Okay? That is what it is there. If it is x, make it as a x only, move to the right. Okay? I will be reaching finally here. Again I see a 1, I modify it as x, move to the left. And I reach to the state Q1, move to the left means I am here. If I see any number of x, make it as x, keep on moving to the left hand side. Finally you will reach here. Are you able to understand? You are in the state Q1, you got the input as D. What it is saying? You modify it as a C. Modify it as a C and move to the left. What is there in the left hand side? D is there. Okay? Your tape head is pointing to this one. And you are in the which state? You are still in the Q1 state only. Again you got a D. Modify it as a C and move to the left. Okay? Move to the left means you are here. And you are in the state Q1. Q1 on B, you got a blank, input blank, and you modify it as a D, move to the right. Right means you will go here and you reach to the state Q0. If you see any C's, they are saying that you make it as C, keep on moving to the right. And if you see any X, make it as X, keep on moving to the right. Finally, you will be here. So, Q0 on blank, keep it as a blank, move to the left. I am moving here. And I got the Q2. So let's see what is the output I got. Here I have the output. My output is DCC. Whether I should get DCC or not. DCC meaning is that 100. So 4 in binary number it will be represented as 100 So this Turing machine will work for any unary number and it will successfully convert into a binary number. I hope you have understood how I have constructed a Turing machine for converting a unary number to binary number. If you have any doubt in this conversion, feel free to ask it in the comment section. I will clear your doubts in less than 24 hours. If you really like my videos, please press the like button and share them with your friends and subscribe to my channel. Thank you for watching my video. Have a nice day.